So that's the power log, the power law for logs. It's probably the most useful one for our purposes. Today we're working on page 375. T is an exponent. We're solving for t. Going to round to 2 decimal places. We take the log of both sides. The base is 10. The t comes down in front. And then to isolate t, I'm going to divide out the log 1.07. Which means t. Sorry, let me write that. Take the log of both sides. So our power law is not defined for this 10 here, so we have to divide it out from both sides. Now we take the log of both sides. So as usual, the exponent comes down in front. I want to solve for this part, so I've got to divide the log 1.08 from both sides. So now, when these two cancel out, you're left with t plus 2 and so t First I'm going to divide out the 25. This is actually a nice example because you can do it with logs or you can do it old school as well. Remember, I'm going to do it both ways. This is the same as, zoom out a little bit. So that's one way. And the other way, of course, is to use logs. Take the log of both sides. I don't know what that is. It's supposed to be log. So I'm going to multiply the t over here. And t is going to be 6 log 1 over 2 divided by log 4. So they want us to know how much of this is going to be left after 90 seconds. They tell us our initial sample size is 50 milligrams, and we know that t is in minutes. So if t is equal to 90 seconds, we need it in minutes, and 1 minute is 60 seconds. T is equal to 90 over 60, or 3 over 2, or 1.5. So A of 1.5, or in other words, how much is going to be left after 1.5 minutes? 50, 1/2, 1.5 over 3.1. You can see that's roughly half. So it's about 1/2 of a half-life. Put that into your calculator. Five zero times 1 over 2 exponent 1.5 divided by 3.1 equals 35.75. So 36 milligrams. Okay? How long will it take for this sample to decay to 10% of its initial amount? So 10% of 50 will give us 5 milligrams. So how do we work that out? Essentially what we're trying to find out is, this is A, we want to find out what T is. So we have 5 equals 50 to the T over 3.1. So I'm going to divide out the 50. Now, take the log of both sides. This is going to give us log 0.1 multiply out the 3.1. So about 10 minutes. So I want to solve. I'm going to take the log of both sides. It's going to give me x times log 2, x minus 1 times log 3. Expand this out. X times log 3 minus 1 times log 3. Move this to the other side. And move this to this side. So positive log 3 from there becomes x log 3 minus x log 2. Factor out the x. Divide out the bracket. And so x is equal to exactly log 3 over log 3 minus log 2. I'm going to use the same strategy here. I'm going to take the log of both sides. On this side, I'm going to get x minus 2 log 5 x times log 5 minus 2 log 5 equals x log 4. So I'm going to move this to the other side and bring the x term onto this side. Factor out the x. And then x is going to be exactly 2 log 5 over log 5 minus log 4. So if I take the log of both sides, multiply out 1 times log 8 x times log 3 minus 1 times log 3. So I'm going to bring this one over here and bring this one over here. So log 8 plus log 3 equals x log 3 minus x log 8. Factor out the x here. I'm going to bring everything to the left side. going to use the substitution here. Now it's going to become y squared minus 7y plus 12. So this tells us that y minus 3 is equal to 0 and y minus 4 equals 0. So y equals 3, y equals 4. Remember that y is actually 3 to the x. There's an integer 1 here, so this means that x is equal to 1. 3 to the x equals 4. I'm going to take the log of both sides. The x will come down. And then x is going to be log 4 over log 3. They said where necessary, round to 2 decimal places. So log 4 divided by log 3, x is equal to 1.26. Two answers. I'm going to bring this to the left side. It's going to become 5 to the x positive plus 5 to the x, which is already there, minus 3 equals 0. 2 times x is the same as x times 2, so I can write that as 5 to the x squared plus 5 to the x minus 3 equals 0. I'm going to use a substitution, and I'll let y equals 5 to the x. This is going to give me y squared plus y minus 3 equals 0. I'm going to use my quadratic formula. Y is equal to negative 1 plus or minus the square root of b squared minus 4ac all over 2a. One squared is 1, negative is positive, 1 plus 12 is 13. This is going to tell us that y is equal to negative 1 plus radical 13 over 2, or y is equal to negative 1 minus radical 13 over 2. So 5 to the x is equal to, now this as a decimal is negative 1 plus radical 13 divided by 2, 1.30. So if I take the log of both sides, x log 5 is equal to log 1.30, and so x is equal to log On my calculator I get 0.16. We also had this option. So if you look at this, -1 minus radical 13 is equal to -4.6 divided by 2 is -2.30. This is interesting because when we write 5 to the x equals -2.30 and you take the log of both sides, that's when you run into the difficulty, because log is only defined for that argument greater than 0, so this can't be negative and it can't be 0. So from this side, no solution. So that's our only answer. Alright, so this one, if you're paying attention, you'll notice right away that 8 divides into 24. So right off, if I start by dividing both sides by 8, on this side I have 3 to the exponent 2x plus 3, and on this side I have 8 divides into 24 3 times. You know what this is? Ninja 1. So this tells us that 2x plus 3 is equal to 1. 2x equals 1 minus 3. 2x equals minus 2. And so x, of course, is equal to minus 1. So I use that same technique here. We see that 2 divides into both sides. And if I divide by 2, on the left side I'm going to get 9. And on the right side I'm going to get 9 to the 2x minus 1. And of course the exponent here that's not specified is Ninja 1. And since we have two powers with the base 9, 1 equals 2x minus 1. 1 plus 1 equals 2x, 2 equals 2x. Alright, the trick here is to look for the lowest exponent. And multiply everything by a power of 3, that will get rid of that. What does that mean? Well, you notice I have 3 to the minus x. If I multiply this by 3 to the positive x, minus x plus x will give me 0. And that's 1. Let's try that. So I've got 3 to the minus x times 3 to the x plus 3 to the minus x times 1 plus 3 to the minus x times 56 times 3 to the minus x. All of that is equal to 3 to the minus x times 0. Sorry, I made a typo there. So 3 to the minus x times 3 to the x will give me 3 to the 0 plus 3 to the minus x Alright, here's the trick. Find the lowest exponent of 3. We've got x, we've got negative x. If I take 3 to the negative x and I multiply it by 3 to the x, this will give me 3 to the 0, or 1. So what I'm going to do is I'm going to take everything in this expression, both sides, and multiply by 3 to the x. Careful now, I'm multiplying by something. I'm going to point something out later on. So I've got 3 to the x multiplied by 3 to the x plus 3 to the x multiplied by 1 plus 3 to the x multiplied by 56 times 3 to the negative x. On the other side I've got 3 to the x times 0. 3 to the x times 3 to the x is 3 to the 2x plus 3 to the x plus this 3 to the x and this 3 to the negative cancel. It's going to give us 56, and on this side I've got 0. Note that this is the same as 3 to the x squared, 3 to the x if I let y equal 3 to the x, this becomes y squared plus y plus 56 equals 0. Since we can't factor that, we're going to try and use the quadratic formula, and y is going to look like negative 1 plus or minus square root of b squared minus 4a, which is 1, times c, all over 2a. Notice this, we're going to have square root of a negative. This means that there are no solutions. There's nothing wrong with the technique, there are just no solutions. Alright, let's try that over here. Notice that we've got 4 to the negative x, we've got 4 to the x, so the lowest exponent is 4 to the negative x, and I need to multiply it by 4 to the positive x to get 1, or to get 4 to the 0. So I'm going to take everything here and multiply by 4 to the x. 4 to the x times 4 to the x is going to give me 4 to the 2x. 3 times 4 to the x. These two will cancel. I'm going to move everything to the other side, and I'm also going to rearrange. So I'm going to write 4 to the x squared minus 3 4 to the x minus 18 equals 0. Negative 6 times positive 3 will give me negative 18. So I'm going to do a little substitution. Let y equal 4 to the x. Then what I've got is y squared minus 3y minus 18 equals 0. Y minus 6, y plus 3 equals 0. This tells us that y is equal to 6 or y is equal to minus 3. So 4 to the x equals 6 log 4 to the x equals log 6. That's going to be 1.29. We'll try this one. 4 to the x equals 6. Sorry, I'm a liar. Negative 3 log of 4 to the x equals log of negative 3. Your spidey sense starts tingling because remember your log can't be negative. So there's no solution, and our only answer is 1.29.